Okay, we're on the EC guide on step 4. So we need to remove the cap. We're going to turn on the EC probe. It should read as 0. And when we insert this into the vial, it's important that the black area on the probe is entirely immersed in the soil water solution, and also that we don't touch the sides. The black area is what gives the current or EC electroconductivity reading, so that we know how many soluble salts are in this solution. Now it can be highly variable. If I touch the side, I touch the bottom, it's going to change. So we want to make sure that, again, we're in the solution. There we go. We're getting a pretty stable reading. About a 0.54. Okay, we're going to go over the in-field use of the EC probe, and I can use it both for EC and temp. And we want to go ahead and insert it. The black part is going to be the connection that we need to be able to measure the EC. We've got marks for our different depths. I'm going to go down to 2 inches in depth. And for the soil temp, if we want to do that first, we simply hold the button in and we read at 23.7 degrees. What you would want to do then to compare this, you would go to an area that's got residue cover, an area that's got crop canopy cover, and on a hot day you're going to get major differences in soil temp. When it gets too hot, soil microbial processes are interrupted, our nutrient cycling is interrupted, the microbes are not happy, just like you and I are not happy when it's too hot. Also, when it gets too cool, they're going to go dormant, and of course some of the nutrient cycling processes, the different microbial processes, are also going to be interrupted. The other part that we can do is go ahead and do an in-field estimate of EC, and this is in lieu of doing the 1-to-1 test with the vial that we showed prior. And you can simply put the probe in. We saturate the area with a canteen. In this case I got a milk jug of water, and it's kind of creating saturated soil conditions. And we can compare it. If you remember, we read about 0.55 when I did it with the 1-to-1, and this isn't too bad. We're reading about a 0.45 EC. And so what we could be picking up here, this is an area that's non-saline. We could be picking up nitrates that are in the soil, possibly some other nutrients such as sulfates that are showing up, soluble nutrients that are showing up as a soluble salt. So this is kind of a quick, easy way to compare it. Sometimes you can take areas where you've applied nitrogen fertilizer in rows, go ahead and see if that banded area tests higher in EC. Go to areas that had manure, go to areas that had different management, and do comparisons very quickly just by saturating the soil, inserting the probe. And again, I like to usually go about 2 inches deep. To get a good example, you can go as deep as 3 inches with this probe. You can go as shallow as 1 inch. After we measure our EC, we'll save the soil mixture for our other tests, and then we'll record the values and then do some interpretation values of what we just read. And in this case you might do different management areas for EC. We're going to record it in table 4. In this case we had a cornfield. Soil EC was a 0.5. Soil texture was a silt loam. It's non-saline. If we've done our pH, we'd record that. The next value is an estimate of nitrates. If it's a non-saline, you can use the formula at the bottom of the table to estimate nitrate levels. And then you simply go back to the tables in the guide and record what microbial processes may be impacted with an EC of a 0.5 in this example, what crops might be impacted by that level of EC, and then any other notes that you might want. And then talk about the management interpretations, if there's anything special that you needed to be aware of. And so that's basically testing for EC.